So, picture this. It's the dawn of the 20th century, and the world of science is completely stumped. There's this invisible energy just pouring out of certain rocks, and it seems to be breaking the most basic rule of physics, the conservation of energy. It was like a ghost in the machine, and a few brilliant scientists were about to start the hunt.
Okay, let's really get into this. The idea that you can't create or destroy energy was, rock solid. But then you have these uranium salts that could make a photograph, even in the dark, over and over again, with no battery, no power source, nothing. It was like a candle that just never burned out. So the question was, what was fueling this impossible fire?
Now, every good detective needs a tool, right? A clue detector. And for this mystery, it was this thing, the electroscope. This little device was a total game changer. Before, scientists could only really see that these rays existed. But Pierre Curie designed a version that could actually measure how strong they were. For the first time, they didn't just know the rays were there, they could put a number on them. This was the tool that would turn a weird puzzle into a whole new branch of science.
So, our first line of investigation follows two of the most famous names in all of science, as they chase the source of this energy right down to the level of the atom. It's kind of wild to think that one of the greatest scientific quests in history all started as a PhD project. It's 1897, and Marie Sklodowska-Curie is looking for a thesis topic. X-rays were the hot new thing everyone was talking about, but she picked something else. These weird, stubborn rays coming from uranium that most scientists had already kind of moved on from. She saw a mystery where other people just saw a dead end.
And almost immediately, she found something that just blew the case wide open. Using her fancy new electrometer, she discovered something that made zero sense. A raw chunk of pitchblende, that's the ore uranium comes from, was 4 times more radioactive than pure refined uranium. Now hang on a second. How could the raw stuff be more powerful than the pure element that was supposed to be the source of the power? It was a complete paradox.
And this, right here, is where you see Marie Curie's genius really kick in. She made this incredibly bold, logical leap. She said, okay, if the ore is more radioactive than its main ingredient, then it must contain a secret ingredient, some new, undiscovered element, hiding in tiny amounts but packing an unbelievable punch. She even double-checked by making her own artificial ore, just to prove it. The natural stuff was hiding a secret.
So the hunt was on. Pierre Curie was so fascinated by his life's discovery that he just dropped his own research to join her. And together, they basically invented a whole new way of doing science. You could call it following the glow. They'd take literal tons of pitchblende waste, grind it up, use chemistry to separate it into different piles, and then bring in the electrometer to see which pile was hotter. Then they'd take that pile, separate it again, and just repeat and repeat, relentlessly following the trail of this invisible energy. This was the birth of radiochemistry. And this quote just nails the huge conceptual shift she discovered. Before her, everyone thought energy came from chemical reactions, from atoms interacting with each other. But Curie proved that this energy was coming from within the atom itself. It was a property of the element, a fundamental part of its nature. Radioactivity wasn't something atoms did. It was part of what they were.
And all that backbreaking work, it paid off. Big time. In July of 1898, they announced they'd found a new element, and they named it polonium in honor of Marie's homeland, Poland. But they knew they weren't done. There was something else in there, something even more powerful. And by December, they found it. An element so intensely radioactive, it literally glowed in the dark. They named it radium, from the Latin word for
So the Curies had proven that new elements right here on Earth were one source of this mysterious radiation. Case closed, right? Well, not quite. A totally separate investigation was starting to look in a very different direction.
For a long time, yeah, that was the assumption. I mean, it made sense. There was this background radiation everywhere, all the time, so it must be coming from radioactive stuff in the Earth's crust. But a few little observations they didn't quite add up.
The case against a purely Earth-based source started to build piece by piece. First, in 1909, a guy named Theodore Wolff hauls an electrometer up the Eiffel Tower. He figured the radiation should drop way off, but it barely changed. Then, in 1911, Domenico Pacini sinks his electrometer a few meters underwater and sees the radiation drop by a whopping 20%. That proved a big chunk of it was being blocked by the water, meaning it had to be coming from above. This really opened up the question, if it's not all coming from below us, where the heck is it coming from?
And I love this contrast because it really captures the two fronts of this scientific revolution. In one corner, you've got the Curies, in a dusty shed wrestling with tons of ore looking inward to the very heart of matter. And in the other corner, you have these physicists like Victor Hess, who became adventurers, literally flying in hot air balloons to look outward to the cosmos for an answer.
So, on August 7, 1912, Victor Hess makes this incredibly risky balloon flight, going up over 16,000 feet, and what he found was just astonishing. This graph here tells the whole story. Instead of going down as he got further from the Earth, the radiation levels started to go up, and by the top of his flight, they are more than double what they were on the ground. There was only one possible conclusion. Some kind of powerful, penetrating radiation was raining down on Earth from deep space.
So think about that. In just a few short years, these two completely different detective stories, both using the same basic tool, had uncovered two revolutionary truths about the world we live in. Let's just break it down side by side. On the one hand, the discovery of radium proved that new elements on Earth were spontaneously changing and releasing energy. That discovery unlocked the secrets of the atom. On the other hand, the discovery of what we now call cosmic rays proved there's a constant shower of high-energy particles hitting us from space. And that discovery opened up a whole new window to the universe. And at the very heart of both of these stories was this brand new concept, radioactivity. This wasn't a chemical reaction, it was an atomic transformation. It was a process where the very identity of an atom could change, and in doing so, release some of the unbelievable energy locked inside its nucleus.
Now, these weren't just some abstract academic discoveries. These invisible rays would very, very soon have a very visible and profound impact on all of our lives.
I mean, the legacy is just staggering, and it is all around us today. Studying radium gave birth to nuclear physics. Pierre Curie himself saw that it could be used in medicine, which led directly to radiation therapy for cancer. Studying cosmic rays basically gave us our first natural particle accelerator, leading to the discovery of brand new particles like the positron, the first piece of actual antimatter ever found. And of course, understanding all of this is what eventually led to harnessing the atom's power for both good and for evil. And that dual nature, the incredible promise and the terrifying peril, that was not lost on the very people who started this whole thing. In his Nobel Prize lecture way back in 1905, years before anyone was even thinking about atomic bombs, Pierre Curie was already wrestling with what they had unleashed. He saw the potential to do so much good, to heal people, but he also saw, with this really chilling clarity, the potential for unimaginable destruction.
Pierre Curie ended his warning on a hopeful note. He said he was one of those who believed that, in the end, humanity would gain more good than evil from these new discoveries. Now, over a century later, living in the world that was built on the science of those invisible rays, well, that's still the essential question, isn't it?